Hi, I'm Jason with RPC Electronics, and in this video I'd like to show off our new Tortoise interface board. This is for the popular Circuitron under-table turnout switch motor. And we're aware of other similar products on the market, so we're not claiming to be the first ones to come up with something like this, but we think ours is just as good, if not better. It's a little more compact. We went with a smaller terminal block, so it's not quite as wide. Also, we were able to reduce the build cost without sacrificing the quality. I believe we'll be able to offer this on the market a little bit cheaper than some of our competitors. And like I said, we did not sacrifice in quality, and I think you'll find that when you get this. So what I'd like to show you here is I've got a little test setup here. I'd like to show how we're using this. Just in this little demo, and we'll take a little closer look at this. Alright, we'll take a little closer look at our version of the Tortoise interface. As you can see, it's the standard edge connector that's required to connect to the Tortoise. Same 8-pin configuration, plugs right onto it. Doesn't require any soldering to the Tortoise motor itself. So that's that's the one big advantage to this particular device. Also, I mentioned we went with a smaller terminal block, so it's a little more compact, as you can see there. The spacing, for those that are interested, is a 2.5 millimeter or 0.1 inch spacing between each terminal space, and will easily accept a wire up to about 20 gauge or so, which seems to be all it's really required for this kind of setup. The terminal block is clearly marked on the board, so wiring is very, very simple with this. Alright, for our little demo here using our interface, I've got one plugged into a standard Tortoise turnout switch motor here, and you can see there's several wires hanging off of this, including this LED. The simplest wiring is simply just the two outer terminals, which would be for the motor control itself. That's the minimum required connections to this. So if you just simply want to connect this switch motor to a DCC controller to control it, you would just need a compatible slow motion controller, much like this little NCE Switch 8 that I have right here on the bench, and those two wires. That's all it's required to run this thing. I've taken a step further to show these other terminals in use that are on our interface board. In this case, I've got a bicolor red-green LED that is connected to the two common pins, which are the two center pins. Also, it's worth mentioning the pinout of this terminal block is in line with the pinout on the switch motor itself. So we did not invert anything, we didn't switch any connections around. Everything is in line with the connections on the switch motor itself. So by having the LED connected to those two common pins, we can now simulate whether the motors, if the turnout is thrown or on the main way, and that's simply done by feeding the internal double pull double throw switch that's inside the switch motor with inverted 5 volts. Whether it's one direction, the polarity of the 5 volts is in one polarity, and when it switches over, it will reverse the polarity and it will change the LED color. I've got a NCE power cab connected here to demonstrate that. So right now you can see that it is lit green, and I'm simply going to just do a switch, and you can see that it turned red, and that was simply achieved by providing 5 volts to the interface. I will put up a diagram on the screen that will show how this is wired up, but the real magic is in the double pull double throw switch that is actually inside of the switch motor, and that's what's actually flip-flopping that voltage back and forth, the polarity of the voltage. By the way we have it wired up, we're using that switch to our advantage. And as you can see, if I have the motor switch back, it's going to switch to green. Now you might notice there was a slight delay there between green and red and green, and that's because as the switch motor is switching over or rolling over, the switch in there has a little bit of a dead spot right in the center. So as the switch is switching, it will hit that dead spot. There's no voltage at that point being provided to the LED or to these pins. And then as it comes over that center point a little bit further, then it will switch over to the other side. So that's why you see that slight delay in the LED there. And you would see that with anything that was connected to this. You would see that slight delay. And that has to do with the slow motion of the motor itself. If the motor was faster, you would either see a shorter delay or maybe not see a delay at all. Say if it was like a snap track kind of switch, but in this case it's a slow motion. So thanks for watching. We will have these on the website for sale, and they're ready to ship now. So if you have any questions, feel free to email us at the website, and we'll be sure to get back to you as soon as possible. I'm Jason. Thanks for watching. We'll see you next time.